When we think of space, we imagine a place that follows strict rules. Gravity pulls. Stars shine. Planets orbit. Black holes swallow. The universe is vast and strange, but surely it is consistent. Surely it makes sense. And yet, again and again, astronomers point their telescopes at the sky, only to find things that break the rules. Things that by all logic, by all equations, by all predictions, shouldn't exist. And still, there they are. The universe, the rule breaker. Science is built on patterns. You observe, you measure, you predict. When something falls outside that pattern, it forces you to rethink everything you thought you knew. In space, these moments happen more often than we like to admit. It could be a planet too big for its star. A black hole too massive for its age. A galaxy that shouldn't have formed so early. Every time, the message is the same. The universe is not a neat machine. It's wild. And sometimes it throws us curveballs that leave scientists scratching their heads. Example 1. The impossible star take SMSS J031 300.36670839.3, known simply as the star with almost no iron. According to our models, the first stars in the universe, the so-called population 3 stars, lived fast and died young, exploding into supernovae that seeded space with heavy elements like iron. Later stars like our Sun formed from this enriched material. But this one star in our Milky Way contains almost no iron at all. Its chemical fingerprint is nearly pristine, as if it came straight out of the early universe, and yet somehow it's still here, billions of years later. By all accounts, it shouldn't exist. But it does. And because it does, scientists must rethink how the first stars lived and died. Example 2. The two big black holes. Then there are the black holes that are simply too big, too soon. In the very early universe, just a few 100 million years after the Big Bang, astronomers have spotted quasars, galaxies powered by supermassive black holes millions, even billions of times the mass of the Sun. The problem? According to physics, there just hasn't been enough time for black holes to grow that big. They would need to eat matter at impossible rates. And yet, when the James Webb Space Telescope looked deep into the early cosmos, there they were, enormous black holes burning brightly, defying all timelines. If they exist, and they do, then maybe our understanding of black hole formation is incomplete. Or maybe something entirely new is at play. Example 3, galaxies that shouldn't be. In 2023, Webb also spotted galaxies so massive, so well-formed, so soon after the Big Bang that they shocked the entire astronomy community. These galaxies, nicknamed the impossible galaxies, seem to contain as much mass as our Milky Way, but they were seen at a time when the universe was less than 1 billion years old. By all logic, galaxies that large should have taken billions of years to form. But the universe didn't wait. It built them anyway. And in doing so, it broke one of the core assumptions of cosmology, the timeline of structure formation. Example 4. The planet that shouldn't exist, closer to home, there are planets that defy expectations too. Take the so-called hot Jupiters. Gas giants larger than Jupiter, orbiting their stars in just a few days. When astronomers first found them, they were stunned. According to models, gas giants should only form far away from their stars, where it's cool enough for gas to condense. And yet here were planets sitting so close to their stars that their atmospheres boiled. These planets weren't supposed to exist, but they did. And they forced scientists to rethink how planetary systems form and migrate. The universe loves surprises. Each of these discoveries points to the same truth. The universe has a way of humbling us. We build equations, models, and simulations. We think we've captured the rules. And then reality throws something at us that shatters the model. Maybe it's telling us that our rules are too simple. Maybe the universe is more flexible, more creative, more strange than we imagined. And maybe that's the point. A philosophical detour. Shouldn't versus can. There's also a deeper question hiding here. When we say something shouldn't exist, what do we mean? We mean it doesn't fit our models. It doesn't obey our predictions. But the universe itself clearly disagrees, because it's there. So perhaps the real lesson is this: what shouldn't exist is just what we haven't understood yet. What we call impossible is only the edge of our current knowledge. Beyond that edge is mystery. Ancient echoes, strangely enough, this isn't a new idea. Ancient cultures filled the sky with impossible things: gods, dragons, cosmic serpents, celestial palaces. To them, the heavens were full of wonders beyond reason. Now, with telescopes instead of myths, we're finding that the universe really is stranger than we thought. The dragons may be gone, but the mystery remains. The pattern of the impossible. Look closer and you'll notice a pattern. Every time we find something that shouldn't exist, it forces us to grow. The star with almost no iron pushes us to refine stellar evolution. The giant early black holes push us to rethink how gravity builds. The impossible galaxies force us to rewrite cosmic history. The hot Jupiters expand our understanding of planetary systems. Each impossible discovery is a clue, a crack in the wall, a glimpse of a bigger truth. Could there be more? If these are just the examples we've found so far, what else is out there? Stars powered by physics we don't yet know? Matter that isn't matter as we define it? Life itself in forms we can't imagine? The universe is vast. We've only seen a tiny fraction. The things we've labeled impossible might be just the beginning. The role of mystery. So where does this leave us? It leaves us in a universe where mystery isn't a bug, it's a feature. A universe that invites us to keep asking, keep exploring, keep expanding the boundaries of what we think is possible. What shouldn't exist does. And because it does, we must grow. So the next time you look up at the night sky, remember this: those stars you see, they're just the surface. Behind them are galaxies that defy timelines. Black holes that grew too fast. Planets in impossible orbits. Stars with chemical fingerprints that shouldn't be real. The universe is full of things that shouldn't exist. And that's why it's so endlessly worth exploring. Because every impossible discovery is really just the universe whispering to us, "You still don't know me."